Hello, hi everyone. Welcome to the Student the Brand. This is our Sebasa. Today topic is light reflection and diffraction. Light reflection and diffraction. So, light is a form of energy. Light, light reflection and refraction. Light reflection and diffraction. So, in this topic, we'll discuss about plane mirror, image formations, plane mirror and image formations of concave mirror and convex mirror. Concave mirror and convex mirror. Here you can observe. So I am taking the plane mirror. This is the plane mirror. So one side is reflecting surface, another side is silver coated. The light ray which is incidenting on the surface is called incident ray. This is incident ray. And the light ray which is reflecting back is called reflected ray. And the line which is perpendicular to the plane surface is called normal line. The light ray which is perpendicular to the plane surface is called normal line. This is the normal. The angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Simply we can say the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, so incident ray, reflected ray, normal ray. Incident ray, reflected ray, normal ray. Okay. Now, so the line which is deviating through the surface, the light ray which is deviating through the surface is called undeviated line. Okay, so this undeviated line. Actually, in a homogeneous medium, there are two types of medium. So homogeneous medium and heterogeneous medium. In a homogeneous medium, light travels in a straight line path. In a homogeneous medium, light travels in a straight line path. In a heterogeneous medium, okay, light ray changes its direction. Homogeneous medium, okay, so the properties of the particle exhibit similar nature. Okay, so entire particle, what are the particles are present in that medium exhibit similar properties. That is called homogeneous medium. Coming to a heterogeneous medium means the medium, the particles present in that medium exhibit different properties. So that is a heterogeneous medium. Homogeneous medium and heterogeneous medium. Now we are talking about, so if it is homogeneous medium means light ray moves in a straight line path. If it is homogeneous medium means light ray moves in a straight line path. Yes, right. So here I am taking this one. So it is undeviated line. Actually it is undeviated. Okay. So without any deviation, normally how light ray will passes, that is the direction of the incident ray. So here the angle between reflected ray and undeviated line is called angle of deviation. Once again, the light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is perpendicular to the plane surface is called normal line. The angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. And angle between reflected ray and undeviated line is called angle of deviation. Okay. So on linear angle, so what is the angle? If you are taking the linear line, so on 180 degrees will be there. Okay, linear. So total is 360 degrees. So if you are taking linear angle, 180 degrees. So from loss of reflection. So coming to loss of reflection is nothing but, so what are the loss of reflection? Point number 1, incident ray, reflected ray, normal line lies on the same plane. Point number 1, incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies. Incident ray, reflected ray, normal line lies on the same plane. So point number 1. Point number 2. Point number 2. It is physics class, CBSE grade 10 physics. CBSE grade 10 physics, light reflection and diffraction chapter. Okay. So incident ray, reflected ray, normal line lies on the same plane. Point number 1. Point number 2. Angle of incidence is equal to angle of reflection. These two are laws of reflection. Once again. So incident ray, reflected ray, normal line lies on the same plane. Lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. I hope it is very clear. So these are the two laws of reflection. Two laws of reflection. Clear? Two laws of reflection. Now, so we can take angle of incidence plus angle of incidence plus angle of reflection plus angle of deviation equal to, you can observe here, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Yes or no? Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Now, from laws of reflection, we can write angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So because angle of reflection, we can write angle of incidence in the place of angle of reflection. In the place of angle of reflection, shall I write angle of incidence? Now angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence. And also we can also write here. Here we can observe in the angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection, right? Angle of incident is equal to angle of reflection. In that way, angle of deviation equal to 180 minus 2 angle of reflection also we can write, because in the previous case, so instead of angle of reflection, we took angle of incident. That's why we got it. The same thing. So instead of angle of incidence, if I write angle of reflection, we'll get this one. Understood? I hope it is very clear. So this is about what is it about? Reflection of light. Reflection of light and laws of reflection and angle of deviation. I hope it is very clear. So do you have any doubt on this? No. Okay, done. Okay, now, so I'll discuss image and object. Image and object we'll discuss. So I'm taking like this. So this is the object. This is the object I'm taking like this. Okay. So from this one, light rays are coming, and here also light rays are coming. So these are reflector light rays. These are reflector light rays. Okay. Hi. And if you are extending these light rays, so this is a real object and a virtual image. And if you are taking one more, So in this case, you observe light rays are coming from object. After action, those light rays are meeting at one point. If you are extending these light rays, so here image virtual object will be there, virtual object and real image. So here, listen carefully. Here you can observe from this point light rays are coming. So this is the point where real light rays. So this is a real object. Light rays are coming from this object. Okay. So after reflection, those are moving away from the principal axis. If you are extending these reflector light rays, extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Okay. So extended reflector light rays are meeting at one point. Here, this is a reflector ray, this also reflector light ray. We are extending this reflector light rays. After reflection, those light rays are meeting at one point. That is the virtual image. Here you can observe light rays are coming from the object. After reflection, those light rays are meeting at one point. So the real image. If you are extending these incident light rays are meeting at one point. So their virtual object is forming. So we can conclude that by observing these two diagrams, we can conclude that so object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Okay. So now you can see I'm concluding this point. So object and image. Object is real, image is virtual. Object is virtual, image is real. Understood? So here you can observe these two diagrams. If you observe these two diagrams, we can conclude that one point, that is real object and virtual image. Real image, virtual object. Understood or not? So object is real, image is virtual. Object is virtual, image is real. So by this we can conclude that like that we can do it. Understood? Next one, nature of the image formed by the plane mirror. We'll discuss about nature of the image formed by the plane mirror, right? Chalo. Nature of the image formed by the plane mirror. So now, I'm taking this plane mirror like this. So this is the object. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I'm taking here, this is the object. So 1 light ray I'm taking like this. Okay. And if you are extending this light ray, this is also incident ray and this will be reflected ray. Normally when the light ray is passing along the normal line, if the light ray is passing along the normal line, what happens? It retraces its original path. So if you are taking, if the light ray is passing along the normal line, so I am taking like this, if the light ray is passing along the normal line, so it retraces its original path, it moves in the same direction. So angle of incidence is 0, angle of reflection is 0 and angle of deviation is 180 degrees. Because so the reflected ray, so in the same direction, incident ray and extended incident ray. So reflected and extended incident ray we are taking like this. So 180 degrees. Angle of deviation is 180 degrees. Okay, I hope it is very clear to you, right? Now we will discuss about one more. So here you can observe light ray is passing along the normal line. So it moving like this, and I am taking one more light ray. So here this one also I am taking like this. So this one we can arrange because virtual image will form, right? So virtual image I am taking. So AB, height of the object. So A dash and B dash. A dash and B dash. Understood? Actually, this is a plane mirror. Okay. So observe carefully. Is it clear or not? Check once. AB, A dash, B dash. AB, A dash, B dash. So point number one, first point is, if object is real, image is virtual. If object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. So point number two, object distance. So what is object distance? The distance between object to mirror. The distance between object to mirror is equal to the distance between mirror to image. So object distance is equal to image distance. And coming to the third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. And coming to the fourth one, magnification of the plane mirror is +1. M equal to +1. Okay, magnification is +1. Understood? So listen carefully. Here, object is real. If object is real, image is virtual. If object is virtual, image is real. Point number one. Point number two, object distance is equal to image distance. Object distance is equal to image distance. And coming to the next one, height of the object is equal to height of the image. Height of the object is equal to height of the image. And coming to the fourth one, magnification of the plane mirror is +1. Magnification of the plane mirror is +1. So this is the nature of the image formed by the plane mirror. Understood? Next one, we will discuss about concave mirror and convex mirror. Concave mirror and convex mirror, right? Concave mirror and convex mirror are spherical mirror. The mirror which in the form of curved shape, the mirror in the form of curved shape is called the mirror which in the form of curved shape is called spherical mirror. So spherical mirrors are divided into two types: concave mirror and convex mirror. Concave mirror and convex mirror. So now I am considering here. So this is the curvature like this spherical mirror. So I'm taking the small portion. So this is a small portion. Depending on reflection of light. So if you are taking like this, reflection takes place inward. If you are taking like this, reflection takes place outward. So depending on the reflection of light, so mirrors are divided into two types: concave mirror and convex mirror. Concave mirror and convex mirror. Now I will explain. Listen carefully. So I am taking the here I am taking the concave mirror, the mirror whose reflection takes place inward. So the mirror whose reflection, after reflection of light, those light rays are converging. Okay, those light rays are converging and meet at one point. So concave mirror is also known as concave mirror. Concave mirror is also known as converging mirror. Converging mirror. Converging mirror. Concave mirror is also known as converging mirror. Whereas convex mirror is known as diverging mirror. Diverging mirror. So I am taking like this here. Sir, why you are calling concave mirror as a converging mirror and convex mirror is a diverging mirror? Because so whenever light rays are incident on it, it reflect and meet. Those light after reflection, reflector light rays are moving towards the principal axis. Here you can observe After reflection, those light rays are moving away from the principal axis. After reflection, those light rays are moving away from the principal axis. So this mirror is also known as diverging mirror. Convex mirror is also known as convex mirror. Convex mirror is also known as diverging mirror. Diverging mirror. Diverging mirror. Concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. I hope it is very clear to you, all right? Once again, I'm explaining. So after reflection, all reflector light rays are moving towards the principal axis. So moving, coming closer or converging. Mirror is converging the light rays. Whereas here, convex mirror, after reflection, light rays are moving away from the principal axis. Moving away from the principal axis. So that's why it is called diverging mirror. Converging mirror and diverging mirror, right? Next we'll discuss about ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. Okay, ray rules. Ray rules of concave mirror and convex mirror. Ray rules. First one, concave mirror. Concave mirror. Concave mirror ray rules we'll discuss. So I'm taking the concave mirror like this. So before that, we'll discuss about terms related to spherical mirror. So anyway, concave mirror only. So but still. So before doing this one, we will discuss about terms related to spherical mirror. Terms. Okay. So center of the imaginary sphere. Actually it is center of the imaginary sphere in which mirror is a part. So still we are taking the concave mirror. So we are considering the concave mirror like this. This is a concave mirror. Concave mirror. Okay. So the mirror whose reflection takes place inward, that is called concave mirror. Here the midpoint of the mirror is called pole. The midpoint of the mirror is called pole. And the center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. The line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called principal axis. Point number 1, center of curvature. Point number 2, pole. Point number 3, principal axis. Principal axis. Okay. So principal axis. Point number 4, the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole. So the distance between center of curvature to pole is called radius of curvature. This is a radius of curvature. Radius of curvature. And coming to fifth one, after reflection, all light rays will meet at one point on the principal axis. After reflection, light rays will meet at one point on the principal axis. So that is called focus. So here you can observe after reflection. So I am taking one light ray like this and another light ray I am taking like this. After reflection, those light rays are meeting at one point here. Okay, so this point is called principal focus. Simply we can say. So focus, principal focus. Coming to 6-1, the distance between focus to pole. The distance between focus to pole is called focal length. This distance is called focal length. Okay, so small f. Coming to the seventh one. So width of the mirror, reflecting surface. Okay, so here we are considering like this. Now, aperture, aperture, aperture. Okay, so this is about central curvature, pole, principal axis, radius of curvature, focus, focal length, and aperture. Width of the mirror is called aperture. So these are the terms related to spherical mirror. Coming to next one, rare rules of spherical mirrors. Rare rules. Okay, so I am considering like this. Now, rare rules of concave mirror, rare rules of concave mirror, concave mirror, concave mirror, concave mirror. So I am taking the concave mirror like this. So pole, focus, center curvature. Pole, focus, and center curvature. So one light ray I am taking like this. So another light ray, point number 1, and point number 2. So pole, focus, central curvature, light ray is passing through focus. After reflection moves towards infinity. Coming to third one. So pole, focus, central curvature, light ray is passing, okay, like this. So next one, fourth one. So I'm taking here. So pole, focus, central curvature, light ray is incidenting at the pole, it reflect back. Okay, so these are the 4 rules of concave mirror. 4 rules of concave mirror. We'll discuss about convex mirror. Convex mirror. Okay, convex mirror rules. Convex mirror rules we'll discuss. So I'm taking the convex mirror. Point number 1. So pole, focus, central curvature, light ray is coming from infinity after reflection passes like this. So it passes through focus. Point number 1. So coming to point number 2. So ray rules. I am taking a convex mirror like this. Here, this the pole, focus, central curvature. Light ray is coming through the focus. So you have to draw like this. Passes through focus. So after reflection, it moves towards infinity. After reflection, it moves towards infinity. Okay. Yes, of course. And coming to third one. So problem solving in the sense image formations, it will be helpful. Where you place the object, how image will form. So according to the object distance positive or negative, image distance positive or negative, and where image will form. So directly they won't directly they won't ask in the problem like draw this type of diagram where object like this. So they will give the data. They will give the data, object distance, image distance, so on. So they will give, and with the help of this one, draw the and find out the focal length and draw the image formation. At the end, they will ask about draw the image formations. Okay. So that is our answer. Directly they won't ask, but they will give the data. Okay, they will give the data. Hello, hi everyone. Welcome to the Story in the Brand. So hi everyone. Yes. Okay. So now we'll see. I hope it is very clear. Next one. So pole, focus, center of curvature, pole, focus, and center of curvature. So light ray is passing through focus. Light ray is passing through focus. Huh? Why it is too much? What I did? What happened? So this is a center of curvature passes through focus. Mm-hmm. So it passes through center of curvature. And coming to fourth one. So pole, focus, and center of curvature. Light ray is incident at the pole. Everyone have their own individuality to teach, right? Like a different style. We can say style. We can say uh, something like that. Okay. So this is my teaching aid. See, I am teaching normally. This is a live class. Okay, just example. This is a live class. I am teaching. Okay, I am not taking anything from anyone. At the same time, I am teaching from past 5 years onwards. You can check my YouTube channel. There are number of videos. So related to physics, especially only physics I am teaching. Then check once if you want know about more about things channel. Once go and check the YouTube channel. There are many number of videos are there. Oh, okay, then fine. So I hope maybe it's individual opinion. I respect that. So next one we are going to the next convex mirror. Convex mirror. Okay, thank you for your suggestion, Dr. Ravi. Thank you so much, Ravi sir. So definitely I will take it as a positive positive what we can say suggestion. Definitely I'll accept. So next one, convex mirror. So I'm taking like this. So ray rules completed. Image formations will discuss. Thank you so much. Thank you so much, Dr. Ravi Garu. Thank you so much. So, pole, focus, and center of curvature. Pole, focus, and center of curvature. So, object is at infinity. So, one lighter I am taking like this. Another lighter I am taking like this. So, after reflection, the light rays are meeting at one point. Focus. And here also. Here you can observe image is forming at focus. Nature of the image is real and inverted, and size of the image is highly diminished. So image is forming at focus. Point number 1. Coming to point number 2. So image formations are very important. So this is the pole, focus, center of curvature, pole, focus, and center of curvature. Object is placed beyond center of curvature. Thank you, Prithviraj Garu. So, really. So, one lighter I am taking like this. So, I am considering like this. So, object is placed beyond center of curvature. Diminished in the sense. See, star gaming, you have many questions from starting onwards. Sir, keep on posing the questions. Yes, it is for grade 10, light reflection refraction. I'm teaching for grade 10 now. Grade 12 students also can listen because it will be helpful for them also. It is in optic chapter. Okay, it is an optic chapter. You can listen. And diminished in the sense, star gaming. So I'm seeing all your questions. You keep on posing your questions. So one after another, I can understand. Okay. So here it is diminished in the sense reduced. Size is decreased. Aditi, hi. And don't you? Okay. So object is placed beyond center curvature. Image is forming between C and F. Nature of the image is real and inverted. And size of the image is diminished. Next one now, third one. So pole, focus, center of curvature, pole, focus, and center of curvature. Okay, object is placed at C. Image also will form at C itself. One light I am taking like this, it passes through focus. Another light ray I am taking, so it incident at the pole. It reflect back. Object is at C, image also will form at C. Nature of the image is real and inverted. Size of the image is same size. Okay. Next one, fourth one. So coming to the fourth one. So pole, focus, center of curvature, object is placed between C and F. One light I am taking like this, it passes through center of curvature. Another light ray incidenting at the pole, it reflects. So image will form here. Object is placed between F and P. Oh, C and F. Object is placed between C and F. Object is placed. Concept is visible, no? If content is there, no need of cutout. So I'm taking here. So C and F. So nature of the image is forming beyond C. Beyond C. Nature of the image is real and inverted. Size of the image is enlarged. So after this position, the image will be enlarged only. So before this one, the image is diminished. Yeah, of course. Is it true or not? Giving? Yes or no? If you agree, you can answer. Yes. So for focus, center of curvature, object is placed at F. How many light rays are required to form the image of the object? How many light rays? So minimum 2 light rays are required to form the image of the object. Yes or no? So one light I am taking like this. So after this it will be moving at a time. Whoa, gaming. Wow, both are responding. Hey, both are same or different? Mr. T gaming or Star gaming? Huh? Okay, done. Object is placed at F. Image is forming at infinity. Nature of the image is real and inverted and highly enlarged. Oh, different. Thank you. Thank you for your answer. Okay. So I hope it is very clear. So this is the object is placed at infinity. Image is forming at focus. Nature of the image is real and inverted and highly diminished. And here object is placed beyond center curvature. Image is forming between C and F. Nature of the image is real and inverted and highly diminished. Actually diminished. So one polythene, sir. Yeah, of course. So everything me only. Substance. Oh my God. With the two hands. I'm really appreciate you, Star Gaming. Thank you for noting down. Okay, then object is placed at center of curvature. Image also will forming at center of curvature. Nature of the image is real and inverted, and size of the image is same size. And coming to the fourth one, object is placed between C and F. Image is forming beyond center of curvature. Sir. Okay. So nature of the image is real and inverted and enlarged. So here object is placed at focus. Image is forming at infinity. Nature of the image is real and inverted and highly large. Sir, if light rays aren't meeting. See, we are assuming that parallel line rays never meet. We assume that the light rays will meet at infinity. So I didn't mention any object here. If you see, I understand. So I agree. So whatever you said, Mr. T Gaming. Yeah, I didn't mention. So in remaining cases, I mentioned the image. Here you can see image, image, image. But here, where is image? Did I mention image position? No. I mentioned parallel lines. Yes, I can. I will give notes. Actually, I have handwritten notes also. Okay, finally, one student asked about notes. I'm really proud of you. Okay, see here, I have written. So, this is my handwritten notes. So, scientifically designed and everything is prescribed in detail, means written. Okay, so just check once, including, see, there is one beauty of this chapter. Sir, can you please tell? Yeah. So my qualification is BTech mechanical. More than enough, I hope. Done. So here, can you give us the PDF, sir? Yeah, of course. I'll provide the PDF. I'll try to provide a community post. In the community post, I'll post. You can check once. In the community post, you can check. Every day I'm posting the questions. In that, I'll notes now. Notes not is now. It's not possible because already PDF is there, but still PDF is there from. PDF is there. Okay, so everything I'll give, everything I'll provide. That sure. So that's enough. So now I hope it is very clear. This now you can see everything is written clearly. This is my handwritten notes. Understood? So you can check once here. Oh my god. So these empty papers I left for writing more number of questions. Like questions. Concept already written, but questions point of view. This is the first book. Like that, two books I have written. That is for reflection. This is for refraction. This is for refraction. So you can see three definitions for class 9. Class 9 I will take definitely. As of now I am taking for class 10. Class 9 also I will take, and class 10, 11, 12 also I will take. Okay, here you can see all the notes. Okay, everything I mentioned here. So because there are many students are there, they are keep on posing the question. That's why. So you can check here. So I have handwritten copy. So everything. This is my handwritten. I only wrote. Okay, my handwriting only. My book only. Okay. So you can check. You can compare with the strokes, with the all diagrams also. You can see my diagrams also. Everything I have prescribed. So I kept here. Okay. So I'll give the notes. PDF I'll try to give as soon as possible, and 4 chapters I have written the notes, like light reflection, refraction, human and color fluid, electricity and magnetic effects of electric current. 4 chapters notes I have written. I'll try to provide how to write in the board without looking at notes. Huh? Okay, done. So, like you can come to the point. The last diagram I'll explain. So today we'll find out. For JE, already I started JE for grade 12 JE, like a grade 12 topic. For JE I given like current electricity. Just check. You can check in my channel. Sir, class 9 gravitation, please. So it is very easy. I'll explain. Don't worry. So class 9 also I'll start. Those are new to the channel, do like, share and subscribe to Student Brand. Then whenever I am taking live classes, you'll get the updates. By that you won't miss any class. How you'll write? Do JEPYK in short videos. Yeah, definitely I'll do it. I'll try. Because I'm taking live classes. Once it is completed, then I'll start. Okay. Okay. Last one, last diagram. Last diagram, I'll do it. So concave mirror. Pole, focus, center of curvature, object is placed here. One light ray I'm taking like this, it passes through focus. Another light ray is incidentting at the pole, so it will reflect. So if you are extending these light rays, if you are extending, all good, sir, can continue. Oh, thank you so much. I'm happy for you all. So I'm extending like this. So here. So now you can observe here. Now you can observe here. Please also make long videos for a chapter. I'm doing only right long video. This is only long video. Okay, so you check my your channel and asking. The live class I'm taking. Live class itself I'm taking full chapter. Full chapter. Full chapter nearly 1.5 1.5 hour also it is taking. So minimum 1 hour I'm taking for each class. Okay, done. So object is placed between F and P. Image is forming behind the mirror. Behind the mirror. Behind the mirror. Nature of the image is virtual erect and virtual erect and enlarge. Virtual erect and enlarge. Virtual erect and enlarge. Compared to the object, image size is increased. Okay, is it clear? So clearly light rays goes away from each other, but your diagram is so I have to mention, I have to place the scale, then only I'll get. Why you wear this type of clothes, sir? It's not about clothes, it's about teaching it. Okay, so one dialogue is there. The one who doing duty, not only the person, dress also can teach. Which part is the mirror? Huh? Oh my god. Okay, done. So thank you so much for joining and attending, listening and asking doubts and interacting with me. Thank you so much. So do like, share and subscribe to Student the Brand. So all my favorite physics chapters only. Yeah, of course. ಸ್ವಲ್ಪ ಗೊತ್ತು. I hope you can understand. Okay. So thank you so much. So do like, share and subscribe to Student the Brand. If you like the channel, if you like the content. So if you like the content, if you like the channel. Oh, I'm happy by saying those lines. It's very heart touching lines. Covers the part of syllabus of 10th. Okay. Hello sir, I'm in 12th class. Okay, definitely 12th class also it's going on. I am in commerce. Okay. Nima lecture. No. Oh my god. Definitely. I'm happy for you. Mr. T Gaming. I understood whatever you're saying. So I'm also happy for you. And I'm also thanks to you. So I said these two words. Okay, thank you so much. Do like, share, and subscribe to Student the Brand. This is your Siva sir from Student the Brand. So if you like the content, if you like the channel, so you can inform your friends, ask your friends to join to the class, and do like, share, and subscribe to Student the Brand. Whenever I started the live classes, you'll get the notification. Then you can attend the live classes and you can interact with me. Thank you so much. See you in the next class.